come on yet, no. Right, Pythagoras' theorem. So you had question 4 and 5, correct? Right, okay. Anyone need me to do any bit of number 4? Did you check your answers at the back? Yes, no, maybe? No, here, I'll put up the answers very quickly. Part of your homework is to check your homework at the back. So you can come in the next day and just say, I need to do part 4 and 5 because I couldn't do them, etc. 22.1, 22 per course, they'd be on different pages. Okay, so look very quickly down here at the bottom. Number 4. Right, answers are root 13, 2 root 10, so that'd be the square root of 40 if you want to write it like that. If you did it on the calculator, it would tell you 2 root 10. Square root of 53, 2 root 5, that's the square root of 20, 15 and 12. Okay, right, are we good with that?
Yes.
Right, number 5, so on the next page. 24.4, 10.6, 9.8. Okay, right, are we good?
Was there not 6 and 7? Yeah.
Oh, is there 6 and 7 as well? Apologies. 6 is 12.8. And number 7, there's 3 answers. Is there 7, 4, 8.1? Yeah?
Yeah.
Okay, right, are we good? Right, okay, so does anyone need me to, did anyone get any part of number 3 wrong?
No.
Anyone? We're all okay? Any part of number 5? Okay. Number 6? Okay. Number 7? We're okay? Right, so Pythagoras' theorem is nailed. Yes.
I wasn't quite sure how to do
Number
number 7.
7. Okay, so number 7, you just had to count the boxes. Right, okay, so there's a line. Yeah, it's zoomed. So there's a line P and Q. Right, okay. And if you count the boxes from P over to R, right, okay, I think you'll find there's 7 boxes, right, okay, and then if you count the boxes from R up to Q, there's 4 boxes. Is that okay? And then you use Pythagoras' theorem. This is a right angle, this is a hypotenuse, so h squared is equal to a squared plus b squared. This is A, this is B, so h squared is equal to 7 squared plus 4 squared, and that's h squared into the calculator. With that you'll get 49 and 16 is 59, 53. I'm not, no, it's more. It's not 53 at all. 65, yeah. Okay, I wasn't even nearly right. So that means h is equal to the square root of 65, and you would just leave it like that, except for they said give it correct to 1 place of decimal, so you have to press S to D on that in your calculator and round it up to 1 place of decimals, and I think 8.1 was the answer, wasn't it?
Yeah.
Okay, is that alright? Happy? Okay, right, we're moving on to, so when do you use Pythagoras' theorem? There's 2 conditions have to be met to use Pythagoras' theorem. One, it has to be what kind of a triangle? It has to be a right angle triangle, and you use it when you know what? 2 sides, and they ask you for the 3rd side. Okay, so that's when you know to use it, because sometimes they don't tell you use Pythagoras' theorem. They'll just say find the length of this side. Okay, so you have to recognize when to use it. Is that alright? Okay, right. I'm moving on now to sine, cos and tan ratios. Okay, so this is me talking for a minute. Do not write. Do not write, because it won't make sense what I'm writing. Okay, so what people did years ago, right, okay, people, mathematicians, right, they took right, all these triangles, right? So they took loads of them, okay? And they all had the same size of an angle, right? Okay, so the angles are all the same. They all had a right angle. And I'm just going to make up one angle, and I'm just saying, imagine this measured 30, and it's 30 in this one, and it's 30 in this one. Okay, and we know from first year that the three angles in a triangle add to 180. So if this is 90 and 30, that makes 120, so there's 60 left over. So that's 60 up there and 60 up there. But I'm just going to leave out the 60 for the moment. Okay, so this is the hypotenuse, agreed? Right, we're going to add two more labels to the triangle now, right? Okay, I'm going to call this side the adjacent. In English, what does adjacent mean? It means beside, doesn't it? So adjacent means beside. So this is the line that's beside the 30, agreed? Because adjacent means beside. And we're not going to write the word adjacent, we're going to write A, right? And this line here is opposite, it's away from the 30, isn't it? So we're going to call that side opposite, right? O for short. Okay? Right, so we're labelling our triangles according to the angle, right? So the line that's beside the angle is called the adjacent, the line that's opposite the angle is called the opposite. With me? So then we did, the mathematicians, they did the same size angle, right, but obviously it's not the same length, sure it's not, but they call this line opposite, this line adjacent, and this line hypotenuse, okay? Obviously, clearly not the same length, okay? This is opposite, this is adjacent, okay? So what the mathematicians did was, right, they took the length of the opposite side and they divided it by the length of the hypotenuse side in this triangle. They took the length of the opposite side and they divided it by the hypotenuse in that triangle, right? And they took the length of the opposite and they divided it by the hypotenuse in this triangle. And guess what? Guess what turned out? They turned out all to be the same, right? So they turned out to be the exact same number, okay? So then they took a note of this number and they put it into your calculators for you, okay? Right? And they call that sine, okay? So every time you divide the opposite line by the hypotenuse, you ended up with the same number when the angle was 30. Now when the angle was 40, they got a different number, okay, for 40. Yeah. So when that angle was 40, they clearly got a different number to when it was 30, but they got the same number when it was 40, 40, 40. When it was 50, 50, 50, they got the same number, right? When it was 50, 40 and 30, they got different numbers, right? So the angles have to be the same, okay? But it didn't matter what length the sides were, right? They always got the same number when the angle was 30. Is that okay? Right? And they call that, so instead of saying, oh, we got the opposite side and divided it by the hypotenuse, they said, let's give it a name for short. So the name for short is sine. Okay? So it reads sin, but you pronounce it sine because the full word is actually got an E at the end of it. Okay? But you'll see that button on your calculator. Get out your calculator and find for me the sine button. Right? Okay? Yeah, so press sine, press 30, and you get a big long decimal, or you'll change it to a big long decimal. So go S to D if it's, I don't know what you get. What you get? 0.5? Yeah, so look, every time they did it, they got 0.5. Okay? Is that alright? So then they went along and said, right, what if we took the adjacent side and we divided it by the hypotenuse? And then in this triangle, they took the adjacent side and divided by the hypotenuse, and the adjacent side and divided by the hypotenuse, and guess what? They got the same number. So it didn't matter what the length of the sides were. When this angle was 30 and there was a right angle, only applies to a right angle triangle. There was a right angle triangle, they always got the same number. And they called this ratio, so instead of saying adjacent over hypotenuse, which is a bit of a mouthful, they said let's call it cosine, right? So the full name is cosine, but it's cos for short. Okay, is that alright? Is that alright? Yeah. Okay, and there's a cos button on your calculator, isn't there? Yeah. Right, so get me the cos of 30 and tell me what number they got. 0.8 something, yeah? Yeah. Okay, so every time they did it, when the angle was 30 and there was a right angle, it didn't matter what size the triangle was, right? Whether it was big or small, it didn't matter, they always got 0.8. And they call this cos, and they put it into your calculator for you. So you don't have to remember all these numbers, because there's a fierce amount of them. Right? Okay? Is that right? And then, yes.
So it's like if you want to find out the answer for like case,
Sorry? I'll tell you why in a minute. So, I think you're right. Okay, the question you're asking, I think you're right. But if you hold that question for a few minutes, I'll tell you why we do all this. And then they did, right, the mathematicians back in the day who had loads of time on their hands to be drawing triangles and dividing numbers, right? They said they took the opposite line and they divided it by the adjacent. So the opposite and the adjacent. And they did the same with a smaller triangle, and the same with a smaller triangle, and they did it with lots of different triangles, and guess what? They got the same answer. So every time the angle was 30 degrees, they got the same answer. And they called this ratio tangent. Guess what it is for short? 10 for short. And you can see that that's the third button on your calculator, isn't it? Yeah. So in this chapter, we'll be using those 3 buttons on your calculator. See them? Sine, cos, tan. Right. Has anyone ever heard any of these before? Yeah. Have you heard sine, cos, tan before? Yeah. Right. Maybe, maybe not. Okay. Right. Okay. So now that was just me explaining how all this came about. But it really doesn't matter how it came about. All that matters is that we know how to use it. Isn't that right? Okay. So, this is for your notes copy. Right? Okay. So, we have sine. I'm going to give them their full titles in the heading. But after that, I'm going to call them sine, cos and tan. Right? So I'll give them their full title in the heading, but after that I'm calling them sine, cos and tan, aren't I? Because that's too many letters to be writing. So sine, cos and tan ratios. Yes. Yeah. Okay. So as I say, we have a right angle triangle. Okay. And you know, for Pythagoras' theorem, I didn't have to mark any other angle. It was just hypotenuse and A and B in any order. Now, for sine, cos and tan, I have to be talking about a particular angle. I'll explain why in a minute. So we're going to talk about this angle A. Is that all right? Okay, so I'm going to be talking about this angle A. Now, this line is the hypotenuse, as always. So the hypotenuse never moves. We'll see in a minute the opposite and the adjacent move around. Okay? So what do I call this line here? Adjacent. Yes, A for short. Adjacent, because the word adjacent in English means beside. So it's beside. So A for short. And I'm going to call this one here opposite and O for short. Is that okay? Are we okay? And then we had the 3 ratios that these mathematicians came up with years ago. So they said sine A is O over H. They said cos of A was A over H. And they said tan of A was O over A. And you all know that when I say O, I mean the opposite, the length of that line. When I say the hypotenuse, I mean the length of this line. When I say adjacent A, I mean the length of this line. So I'm talking about the lengths of the lines. Okay? Right. Girls, you need to remember these. Right? So how you remember these is you learn off this word. Sakatoa. Okay? So it's like a new language for maths. Sakatoa. We just learned a new word. They should put it into the dictionary. Sakatoa. So what it means is sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Okay? So I'm going to put that in a box, and I'm going to put a big learn sign on it, because this doesn't jump into your head, right? And if you were outside the door of my 6th year class today, you would have heard me talking about Sakatoa. So you'll be using it all the way up. Okay, so you have to learn it. And you obviously have to learn it to spell it properly, because the 3 formulas are in it, aren't they? So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. Okay? Right. Okay, a minute ago, can I take that away? Sorry. Is it down? Yeah. I'm recording, so if you want, it'll be on, you can watch the video and pause it, okay, if you want. Okay, right, can I take it away? Gone? Right, okay. So, I said a minute ago, it depends, you know, the hypotenuse never moves. So if I had this triangle, right, okay, and I was talking about this angle up here, so I'll call that angle B, right? Okay, the hypotenuse never moves. It's always straight across from the right angle. So which side, 1, 2, or 3, is the hypotenuse? 1. So this is the hypotenuse over here. Right. What about 2? What'll I call 2? It's beside the angle I'm talking about. So what'll I call it? Adjacent, A, and that leaves this as the opposite. Okay. So a minute ago, I was talking about this angle down here, wasn't I? So the hypotenuse is still here. Look, the adjacent is beside A and the opposite is here. So the opposite and the adjacent move around depending on what angle you're talking about. Does that make sense to people? Yeah. Right, so when I'm talking about this angle, this is the adjacent. When I'm talking about that angle, this is the adjacent. And they will tell you in the question which angle they're talking about. Okay, they don't expect you to decide, right? They will clearly state which angle they're talking about. Is that okay? Right, so the opposite and the adjacent moves around depending on which angle you're talking about. Okay, now, how am I going to deal with this? Right, okay, so if I have example 1, so I have a right angle triangle, so 13, 12, and 5, and there's my right angle, and I'm talking about this angle here, and the question is, just write me down sine of A, cos of A, tan of A. So write me down what sine of A equals, what cos of A equals, and what tan of A equals. Right, and I'll tell you why. We're just practicing how to do these. We'll get to the why in a while, okay? Right, so Sakatoa. So I'm going to write that down, because that's my 3 formulas learnt for me in one go. So what's the formula for sine? Sine, what's the formula for sine? Over h, isn't it? So, sorry, before I started, I should have labelled my triangle. What I call 13? H. What I call 12? A. And I'll call 5? O. Right? Yes? Sorry?
How do you know what to call A?
It's adjacent, it's beside angle A. Right? It's beside the angle I'm talking about. And that word in English, adjacent, means beside. I feel like I'm an English teacher now. I'm not. I can barely speak, but yeah. Right? Okay, so adjacent means beside. So whatever line is beside the angle, that's what you call adjacent, and the other one is opposite. Okay, so you fill in sine of A is O over H. What does O measure? 5, isn't it? What does H measure? 13. That's my answer. They said, write me down what sine of A is. The answer is 5 over 13. That's all we have to do so far. Cos of A. So what's the formula for cos from SOHCAHTOA? A over H, isn't it? So what is A? 12. What is H? 13. There's my answer, 12 over 13. And you leave your answer as a fraction, right, unless they say corrected how many decimal places, okay? But you leave it as a fraction, okay? What's the formula for 10? O over A. So what does O measure? What does A measure? 12. That's my answer. Is that okay? It's not too bad. Sure it's not. It sounds like it's a foreign language, but the questions are okay, aren't they so far? Do you agree? Right, okay. Right. So example 2. Now, for example 2, right, we're going to use Pythagoras' theorem, right, okay, and the SOHCAHTOA, right, so we're going to, what we learned yesterday and what we learned today are all going to be muddled into one, okay, so if I say, if sine of A, no, I say tan of A equals 1 over 2, find sine of A and cos of A. Is that right? Okay, so that's the question. So I've made a jump now, I'm gone hard, right? Okay, so I've gone from an easy question to a hard question. Okay, so what you have to do is draw a right angle triangle, right? What way you draw it is up to you. Okay, so I'm just going to draw a right angle triangle. Okay, now if you want to draw it like so, you can. If you even wanted to put the right angle up at the top, you can. Is that right? Okay, so it's up to you how you draw the right angle triangle. So if we have, I'm going to write down SOHCAHTOA because I know I'll definitely be using that. So I'm just going to have it written there for myself. Okay, so they're telling me 10. So they're telling me 10 of A equals O over, 10 of A equals a half. That's what they told me, is it? Right. Okay, so I know I'm going to be talking about an angle A. So I'm going to mark that angle A. My choice, where I put the angle A. I can put it up there if I want, but down the bottom is probably the easiest. Right? Okay? Right. So then they tell me 10 is a half. So what's the formula for 10? O over A, isn't it? So what does O equal to? 1. So O equals 1. And what does A equal to? 2. Because the O is on top, so it's 1. And 2, A is on the bottom, so A is 2. You all see where I came up with that? Yeah. Okay. So on my triangle, this is the hypotenuse. Would you agree? Yeah. Right. What I call this line here? A. And what I call this one? O. Right? So I've just figured out that O measures 1. So I'll stick it in. And A measures 2. So I'll stick it in. Now, I need to find sine and cos. So H is in sine and cos formula. So I need to find H. How will I find H? H squared equals A squared plus B squared. Yeah? Last night's homework? Yeah. Right? So I'm looking for H. A and B are just the other two sides. So I'll go 1 squared plus 2 squared. Yeah? Into the calculator with that, I'll find out that H squared is equal to 5. So what's H equal to? square root of 5. So look, that side there now measures the square root of 5. You with me?
Yeah.
Right, so that's last night's homework. Pythagoras is here. We can't forget about that. It's very important. Okay? Right. So now the question was to write down what sine of A is and what cos of A is. So sine of A and cos of A. What's the formula for sine of A? O over H. What does O measure? 1. What does H measure? Just found it out. Square root of 5, isn't it? And cos of A, what's the formula for cos of A? A over H. So what does A measure? 2. What does H measure? Square root of 5. There's my answer. Okay? I'll do another one of those now. There's a lot of maths in that, isn't there? Right? Okay, so how am I going for time? I have 7 minutes. I'll definitely have a second example done, won't I?
Yeah.
Right, okay, so example 3. Am I good to go?
Yeah.
Right, example 3. If sine of A is equal to, I'll make it up, 3 over 7, find cos of A and tan of A. So what do I need to do first? What do I need to do? Draw a triangle. Okay? So anyway at all, your choice how you draw the triangle, right? And you mark one of the angles A. So I'll mark that angle A. Right? Okay? Before I move forward, I'm going to write the hypotenuse, opposite and adjacent. So what will I call this line over here? Hypotenuse. What will I call this line here? Adjacent. And that leaves me with opposite. Okay? Is that right? I'll write down SOHCAHTOA. Right? So I know sine of A is equal to 3 over 7. So what's the formula for sine over H? So that just tells me that O equals what? 3. And H equals what? 7. So O is 3 and H is 7. Okay? Agreed? Right. Okay. What do I need to do now? I need to find the third side. How do I find the third side? Pythagoras' theorem, isn't it? So H squared is equal to A squared plus B squared. So that means 7 squared is equal to A squared is 3 squared plus B squared is what I'm looking for, yeah? The other side. With me? And it doesn't matter which you put first. Do you want to put the 3 there or the missing one? It doesn't matter. 7 squared on your calculator is 49. 7 by 7 is 49. 3 squared is 9 plus B squared. What will I do now?
49 minus 9.
Yeah, 49 minus 9 equals B squared. So that means B squared is equal to 40. So B is equal to the square root of 40. Now, if you do that in your calculator, it'll call it 2 root 10. But if you want to leave it as a square root of 40, it's the same number, right? Just written in a different form. So it really doesn't matter. Is that okay? Right. Now, the question was, so I've just figured out that this line here measures square root of 40. Or 2 root 10, whichever I prefer. Right? Okay? So the question was to find cos of A and to find tan of A. So the formula for cos of A is what? A over H. What does A measure? Square root of 40. What does H measure? 7. That's my answer. Okay? And 10 of A, what's the formula? Over A. What does O measure? 3. What does A measure? Square root of 40. There's my answer. Okay? Yeah, leave it as a fraction with a square root sign in it and whatever, it's grand. Unless they say correct one place a decimal, and then you put it into your calculator and press S to D. Okay? But you leave it as a fraction if they don't. Okay? Right.
What are the terms for that? Like, what does that mean?
I'll tell you why in a minute. Why is it's basically if you have what you can do is you can find out, you know, the way you in a triangle, if they give you some information, you can find out all the rest. So in this triangle, I've just found out one of the signs. I can also find out the size of that angle if I wanted to, and I could find out the size of that angle up there. So basically, the y in a while, trigonometry allows us to find out all this. When they give us a little bit of information about a triangle, I can find out anything I want to know about that triangle. Okay? Yes.
How do you know when to see the triangle?
How do you know when to?
The triangle is
When you know two sides of a triangle and you want to find the third side. So I can't fill in these formulas until I know what A is. But that's how I know I want to find the third side. Okay? I'll see you after lunch.